Fluids in motion and Bernoulli's principle. We will now look at fluid dynamics, fluids in motion. Let's consider a fluid that flows smoothly with no friction. This type of flow is called laminar flow. The mass flow rate is the mass that passes a given area per unit time. The mass flow rate must be the same as it crosses any area as long as no fluid is added or removed. So you can see that this is a pipe that gets smaller in diameter, but the same mass of fluid is going to pass by a certain point in a certain amount of time. So here, the mass of fluid is the same as the mass there of fluid. Mass equals density times volume, so the mass that flows past any point is given by this equation here. So remember, density is mass divided by volume, therefore mass is density times volume. And volume of this fluid here is going to be this area of the pipe, the cross-sectional area of the pipe, multiplied by this distance here, which we'll call this x1, and over there it's going to be x2. So instead of volume, we have the cross-sectional area times the displacement along the pipe. And consequently, if we then divide both sides by time, mass per time is going to be equal to density times area times x divided by time. And what is displacement divided by time? But velocity. So now we have a lowercase v in here for velocity. Remember, uppercase v here is volume. Lowercase v is the speed of the fluid. All right, so now we have this equation here. The mass that flows past any point is given by this equation. The amount of mass per time is rho AV. And so we can see that this rho AV has to be equal to this rho AV. And since it's the same fluid and it's incompressible, the density will be the same here and there. Therefore, we have the continuity equation. A1V1 equals A2V2. This is on the AP2 equation sheet, and this tells you the relationship between how fast a fluid is flowing and what the cross-sectional area of the pipe is. Density does not typically change in liquids. This means that where a pipe is wider, the flow is slower. You can see this happening in a river. The water flow is slow where the river is wide and fast when it is narrow, because the same mass of water is going to pass by a point in the same amount of time.